Definitions. In this video, we're going to cover a few definitions that will help us describe the properties and characteristics of electromagnetic radiation. So when describing electromagnetic waves, we describe them as transverse, meaning the oscillation of the wave is perpendicular to its direction of travel, and that oscillation is due to electric and magnetic fields. And we often focus on electric fields as that relates to the plane of polarization. Now in a wave, we have crests being the maximum amplitude of the electric field and troughs being the minimum. Phase is a description that refers to the displacement and direction of two different waves. So if they have a relationship where both emit a crest and both emit troughs at the same time, they can be considered in phase. It doesn't matter so much about the amplitude, it's just if they're emitting crests and troughs at the same time. And in order for this to be true, they have to have the same frequency and the same wavelength. Now, two waves are out of phase when the crests and troughs don't line up. So we've got a few examples on the screen here. At the top on the left diagram, you can see that the red wave has a crest that is 90 degrees later than the blue wave. And so we say that's 90 degrees out of phase, and the bottom one being 180 degrees out of phase. Now they use degrees to represent this due to the periodic cyclic nature of waves. Now two waves are considered coherent if there's some sort of phase relationship between them. So in order for them to have a phase relationship, they have to have the same frequency, speed, and the wavelength. So we can see in the diagram on the screen, at the top here, the blue and red waves are in phase, meaning they both emit crests and troughs at the same time. They have the same wavelength and the same frequency. In that middle one, they're out of phase because the crests and troughs aren't emitted at the same time. However, it's clear that there's some sort of relationship. You can find that easy pattern, and they have the same frequency and wavelength. So the middle one is coherent. Same with the final one. There's that relationship. It looks like it's 180 degrees out of phase, but the waves have the same frequency, same wavelength, and a constant phase relationship, so they are coherent. Alright, this one's an easy one. When light is of a single frequency, it's called monochromatic. Mono meaning one, chromatic representing the color. So incandescence is another definition, and that's when a solid or a liquid is heated and it glows due to the application of the heat. So an examples could be light globe, coals on a barbecue, iron bar that has been heated. For example, when you're doing blacksmithing, you put the iron bar in the fire. Initially it's cold, it's black, but as it starts to heat up, it becomes red hot. Then if you heat it up even more, it becomes orange, yellow, and white hot in the end. Now what's actually happening in these situations is due to the vibrations of the atoms in the material when they're exposed to heat, they're moving in all different directions, and when they move they emit a frequency of electromagnetic radiation. When that heat is hot enough, that electromagnetic radiation appears in the visible spectrum so we can see it, and at that lowest level that's red, and so the first one that we see when we heat something up like an iron bar is that red hot color. If we keep heating it, we introduce energy of orange. The particles are vibrating even more, so the frequency that they produce appears orange to us, and then yellow. But as it keeps going and heating up, we introduce all the colors. We don't so much see the green and the blue when we heat up an iron bar. It's because when we mix all the colors together, they appear white. So it glows white hot. So when we've got something that's glowing incandescent, all the atoms are vibrating in all different directions with all different frequencies, and we have a spectrum of light that's emitted. So the light that's emitted is not monochromatic because there's definitely more than one frequency. It's not coherent because of the different frequencies, nor is it in phase, also again because of the different frequencies. Okay, two scenarios on the screen. Identify which of the following are coherent or monochromatic.